Thanks for joining me. This is a basic overview of SQL Injection for CSET 4850. First off, I'd like to start off by saying that this is a completely controlled environment. I spun this up on my ESXi server, and all of the testing will be done on a closed environment using a nice little system called BRICKS. BRICKS offers quite a few walkthroughs on basic SQL injection. I'm using it for this purpose because it's a nice small testing environment and it's ready to go out of the box with all of the nice little vulnerabilities that are going to be noted in this video. I'd like to take an overview. There's quite a few different methods that are brought to light via this web page and this platform. So take a look if you're interested. First thing I'd like to do is introduce a brief overview of what it is that SQL injection is exploiting, essentially. So in SQL we have a query string. Query string, if you are accessing it via a database, it starts off with a select and then allows the user to specify a column or columns. So we can do call 1, call 2, call 3, or we can just specify to give me every single column that is contained within a table. And next we have a from, and this is the specifier for what table you would want to use to query against. So for this instance we'll use table 1. The next thing that we will see is a where. So this is telling it to search a specific portion of table 1, and in this case we'll just use call 1 as the search column. And after we are searching for that, we have like, and then usually a string to search for against the databases column. There are other features such as wildcards, which should be taken note. This would allow you, if you are not searching for a specific fixed string such as bricks, and you are only looking for a portion of it. So if I do brick, this wildcard is going to return bricks as well as brick, or anything of the variant which has something after brick. So if I were to, say, take off the front portion, we could put a wildcard there as well, and it's quite common for a lot of these search functionality, database search functionality websites to use these wildcards so that it includes everything, even if the user didn't specify as like full string. So the portion that SQL injection takes advantage of is this string right here, and it does so by using a multitude of different features, such as if I leave this string empty as is, it will search for a null value. But say I wanted to search for the name Tom. Okay, well that's great. But what if I accidentally placed another single quote in there and then put Tom? Or if I put a single quote and then put some extra math in there, some extra logic, like or 1 equals 1, and that would return true. So the website would look at this portion and place it in between its already existing single quotes as it runs the query, and it would turn it into a true value. So this is one of the most simplistic strings for causing an SQL injection, and is one of the most simplistic methods for testing an SQL injection. Down below here I have a simple test string. This is a very simple login page. And if I come in here and I type in the name Tom, which has a specific password right now of Tom, and then click submit, it shows us that the login was successful. Now if I am to go in and look at the post data, which is the data that is sent from these two fields upon me clicking submit, and dig a little bit deeper, we can see that this is the information that is being posted to the next page upon submission, and that next page will extrapolate the data in the form of username equals Tom and password equals Tom, and submit. So since we have the information, the fields that are being posted to, we can have a little bit of fun without having direct access to the database itself. So if I use, for example, Tom again in the username field, and I were to use a string quite similar to what I stated previously as the password, as you can see it says wrong username or wrong password. But if we come up here and leave the username as Tom and we modify the post and then we execute and just send the post to the next page, as you can see it says login successful. And effectively that is bypassing that user, that page's ability to check for a legitimate password, because we're interrupting the normal query that would be run by essentially closing the original query, and then we are interrupting it by stating, hey, there's more information here, and we're stating that there's a true value by saying 1 equals 1. So just by doing that, we're forcing the query to return a true, and that's all this login screen is looking for. So you can imagine if I had the username admin and did the exact same thing, and we'll go ahead and clear this out, and I execute this again, we get a successful login. So this could be very, very dangerous, especially if I'm able to get into an administrative account by simply using an SQL injection attack, because that would give me full access to whatever I wanted on that banking website or e-commerce website, you name it. There's a few other things that can be done, especially you can put fun things in there, such as passwords which aren't even close to what would be appropriate. So again, if I replace the username instead of just the password, I can use the injection there as well, instead of just specifying the injection on the password. So we can put a string in here instead, and we can execute that once again, and as you can see, login successful. There are a few things, specifically if I were to say use Tom as the username without trying to bypass any sort of systems, and I put in this as the password, we've got wrong passwords. So what's in fact is happening is we have a front-end system which is looking at the string prior to it being passed and says, I see a few special characters in here, and it doesn't allow the user to go any further. This is effectively a pre-parser which protects the database against injection attacks, but this, as you can see already, just by sending it through the post instead of the submit, I effectively bypassed that altogether. And this can be very, very scary, especially if you're not protecting against it on the back end, which it's becoming more and more common to do so. But still, it still happens to this day, and it's very sad when it happens. There are a few things, such as pre-parsing, which do help to minimize and mitigate the potential vulnerabilities, but they don't necessarily cover up all the holes, and it's kind of a cat and mouse game as far as patching the holes before somebody finds them. And in essence, somebody has to find them and has to be of goodwill or good faith to come forward with those, and not just use them for malicious purposes. There's something else to be said. As of late, there's been a rising use of something called a web application firewall, or a WAF for short. What this does is it acts as a primary pre-parser before the query is sent to your actual servers. So a third party would offer you a service to essentially scan all of your query strings. So anytime a URL is passed on, this post data is also passed on with it. And what these WAFs do is they will scan not only this, but as well as the URL itself. This is not necessarily just upon first visiting the site, but in essence is also when the user is navigating around the site. So even if a user is past the logon screen and they are deep in the site, they can't bypass the normal, they can't execute a SQL injection attack. That's not to be said that WAFs in themselves are perfect. There's instances even where I've seen WAFs completely block the normal functionality of a website's usage. So a user would visit the website, they would be navigating it as if any other person, and it would completely block them from accessing or maneuvering on the site. So they wouldn't get past anything more than the landing page, which this can be very very bad in the case of large e-commerce websites, because it can prevent sales, it can prevent customers from wanting to come back even. But the worst thing of all is as of late there's been a rising number of people that I have seen that have been able to completely bypass WAFs altogether. And there's various different techniques which I won't go into detail about or demonstrate for that matter. But there's different techniques which are coming around right now that are allowing them to even bypass the WAF itself. So, with that noted, I feel like it's more of a better idea to keep an on-site person that has enough expertise to, when they're developing the website, take and keep in mind how the search functionalities and the username, the logins might be manipulated, and protect against them that way instead of going with a WAF only. So as many layers of defense is better. I hope you enjoyed this video. I will be linking the source of this, BRICKS, in the description of this video. I appreciate you watching, and have a nice day.